Famous French philosopher Auguste Comte claimed in 1835 that it would be impossible for humans to comprehend the true nature of stars or their chemical makeup. Fortunately, there was a type of revolution in the field of astronomy in the second half of the 19th century which quickly disproved his theory. Spectroscopy and photography were two new methods that astronomers started to utilize. We can infer that this was most likely the beginning of astronomy. Together, spectroscopy and photography helped bring a new understanding of the cosmos, and for the first time, scientists could examine what the universe was made of. They were able to comprehend both what and how the sun was burning. This marked a significant turning point in the growth of cosmology, a young field. Astronomers were able to note and catalog the characteristics of the stars in addition to their positions. What is spectroscopy, though? And exactly what is astrophysics? In order to understand astronomical objects and phenomena, the science of astrophysics uses physics laws, principles, and the power of physics. Of course, among the subjects investigated are the sun, other stars, and galaxies. Astrophysics also investigates the cosmic microwave background, the interstellar medium, and extrasolar planets. How can scientists investigate these things? How does it work? They research their emissions, I suppose. In actuality, each thing emits its own light, or what is known as its intrinsic energy, which results in a spectrum. All regions of the electromagnetic spectrum are studied for these objects' emissions, and attributes like brightness, density, temperature, and chemical composition are also looked at. Astrophysics is a very broad field that incorporates ideas and techniques from many branches of physics, including nuclear and particle physics, atomic and molecular physics, classical mechanics, electromagnetic, statistical mechanics, thermodynamics, quantum mechanics, and relativity. To become an astrophysicist, one must therefore devote a lot of time to studying. In reality, modern research frequently entails a significant amount of effort in both the theoretical and observational physics fields. Astrophysicists are attempting to understand the origin and ultimate fate of the universe, as well as the characteristics of dark matter, dark energy, black holes, and other celestial bodies. The study of star dynamics and evolution is done in theoretical astrophysics in order to answer the question of how the solar system formed and developed. As we mentioned earlier, astrophysicists investigate the variety of celestial objects. So, what precisely is a spectrum? When a material's temperature is higher than absolute zero, all normal matter begins to radiate electromagnetic energy. The radiation, also known as thermal radiation, is a result of a body's internal energy being transformed into electromagnetic energy. It is a naturally occurring mechanism of entropy radiative dispersion. On the other hand, electromagnetic radiation is somewhat absorbed by all natural stuff. A black body is an object that completely absorbs all radiation that strikes it, regardless of wavelength. When a black body is at a uniform temperature, its emission has a specific frequency distribution that varies on the temperature. Black body radiation is the name of its emission. A star's spectrum is primarily made up of heat radiation, which results in a continuous spectrum. The star radiates light in all parts of the electromagnetic spectrum, from radio waves to gamma rays. Yet, the energy emitted by stars varies depending on the wavelength. All of these phenomena are now common knowledge, but at the end of the 19th century, physicists were baffled as to why the observed spectrum of black body radiation, which had by that point been precisely measured, deviated greatly from that predicted by the theories at higher frequencies. Black body radiation is the thermal electromagnetic radiation that a black body emits when it is in thermodynamic equilibrium with its surroundings, an idealized opaque, non-reflective body. Since there are no flawless black bodies in nature, the idea of the black body is an idealization. Graphite and lamp black, with emissivities greater than 0.95, however, are good approximations to a black substance. Max Planck came up with a formula for the black body's observable spectrum in 1900. Just the radiation's frequency and the body's temperature affect the Planckian function. This is how a typical Planckian function appears. Currently, we know that stars can roughly be compared to dark bodies. Yet, the spectrum they observed is not a precise Planckian function. This is due to the fact that black bodies are an idealization and do not actually exist in nature, as we have previously underlined. As you can see, it differs significantly from the Planckian function in appearance, and it appears that certain lines are missing. What led to them? Before scientists Kirchhoff and Bunsen joined the picture at the end of the 19th century, this was a challenging question to resolve. Nothing remained the same either. It's time to respond appropriately to our second query: spectroscopy, what is it? The study of how electromagnetic radiation interacts with matter as a function of the radiation's wavelength or frequency is known as spectroscopy. Spectroscopy, to put it simply, is the exact study of color, extrapolated from visible light to include all bands of the electromagnetic spectrum. We may claim that spectroscopy was born in 1859 thanks to Gustav Kirchhoff and Robert Bunsen. Kirchhoff had found a totally unexpected discovery, according to Bunsen's report to a colleague. He knew what was causing the dark lines in the solar spectrum. Characteristic bright lines emerged when specific compounds were burned in Bunsen's burner. They occasionally occurred at the exact same wavelengths as the black lines in the solar spectrum. The dark lines represented light absorption in the cooler gas above the surface of the sun, whilst the bright lines represented light emanating from hot gas. The two researchers discovered that each chemical element generates a distinct spectrum. This offers a kind of fingerprint that can attest to the substance's presence. This could be a potent tool for figuring out the chemical makeup of the sun and stars, according to Kirchhoff and Bunsen. They were accurate too. Without spectroscopic surveys, astrophysicists and astronomers today would perish. The way that energy interacts with the material can help distinguish between different forms of spectroscopy. Among these exchanges are: 1. Absorption spectroscopy. Absorption happens when energy from the radiative source is absorbed by the substance. 2. Emission spectroscopy. Emission shows that the substance releases radiative energy. The British astronomer and chemist Warren de la Rue said in 1861 that if we were to go to the sun and bring some portions of it and analyze them in our laboratories, we could not examine them more accurately than we can by this new mode of spectrum analysis. This statement demonstrates the significance of spectroscopy. With a greater understanding of spectroscopy, we can better comprehend how astrophysics investigates the locations, masses, velocities, and all other physical characteristics of celestial objects. In reality, spectroscopy tells us where stars and gas clouds are located. For instance, it helps us better understand how stars are distributed throughout our galaxy. Moreover, we can deduce stellar masses and chemical abundances of elements relative to hydrogen using the so-called virial theorem. And last but not least, we investigate velocities using spectroscopy. How are we doing? Perhaps you are already familiar with the terms redshift and blueshift. As celestial bodies, such as stars or galaxies, travel nearer or further away from us, redshift and blueshift describe how light shifts toward shorter or longer wavelengths. The light is shifted to the red end of the spectrum as an object moves away from us because its wavelengths lengthen. We may determine the object's radial velocity with respect to us by calculating the quantity of the redshift/blueshift. Isn't it incredible? Studying colors is the same as researching the cosmos. What exactly does an astrophysicist do? An astrophysicist may undertake research on the planets, the stars, other galaxies, and things in the cosmos. They use their in-depth understanding of physics to interpret astrological notions. The following duties could fall under the purview of an astrophysicist: create astrological theories and use research methods to put them to the test, keep up on industry research developments, provide information and analysis to the field, analyze and create software and tools to aid astrological research further, encourage the conduct of scientific research to better understand the universe. A lot of physics, math, and astronomy must be studied in order to become an astrophysicist. Jokingly, we could remark that an astrophysicist learns the same physics as a doctor and very much the same arithmetic as a mathematician, in addition to astronomy-related material. What are the primary goals of an astrophysicist at NASA? In contrast to astronomy and astrophysics, which examine individual objects, cosmology analyzes the universe as a whole and its phenomena at the biggest scales. Then, rather than providing answers, astronomy is more interested in watching and measuring the relative positions and courses. On the other side, cosmology and astrophysics attempt to explain the phenomenon. Normally, astronomy students concentrate on using optical and classical mechanics to view celestial bodies and predict their positions in the sky. Nuclear physics and general relativity are two key concepts in astrophysics that are used to describe stars and galaxies. Cosmologists wonder why and how the world came into being, and they are interested in contemporary hypotheses, particularly string theory. Here's where the video ends. Thank you everybody for watching. Are you in love with astrophysics? Do you have any questions or other requests? Please share your thoughts in the comments section below. Be sure to subscribe and I will see you on the channel again soon.